Standard circuit breakers and panels are typically rated for 60 degrees Celsius or 75 degrees Celsius operation. 75 degrees Celsius breakers and panels allow for higher current carrying capacity than 60 degrees Celsius rated devices, which can be advantageous in certain applications. Transformers are typically rated for 90 degrees Celsius temperature rise by resistance. This means that the transformer can operate safely with a temperature rise of up to 90 degrees Celsius above the ambient temperature. The overall rating of a system refers to the maximum temperature it is designed to operate at continuously. The overall rating is determined by the lowest rated component in the system. While standard breakers and panels are typically rated for 75 degrees Celsius operation, it is not safe to assume that all transformers can be wired as 75 degrees Celsius connections. The overall rating of a system should be determined based on the ratings of all its electrical components, including the transformer. If a transformer is rated for 90 degrees Celsius temperature rise by resistance, the overall rating of the system should be considered 90 degrees Celsius, even if the breakers and panels are rated for 75 degrees Celsius. When dealing with electrical systems, it's critical to understand the temperature ratings of different components. These ratings dictate the maximum safe operating temperature for each device and play a vital role in ensuring the system's overall safety and performance. Focusing on breakers, panels, and transformers, it's essential to recognize that each component may have a different temperature rating. Standard circuit breakers and panels are commonly rated for either 60 degrees Celsius or 75 degrees Celsius operation. The higher 75 degrees Celsius rating allows for a greater current carrying capacity compared to devices rated at 60 degrees Celsius. This can be particularly advantageous in applications where higher currents are expected. Now let's move on to transformers. These are usually rated for a 90 degrees Celsius temperature rise by resistance. This rating signifies that the transformer is designed to operate safely with its internal temperature rising up to 90 degrees Celsius above the surrounding ambient temperature. It is essential to avoid exceeding this temperature rise, as it could lead to insulation breakdown and potential failure. The overall rating of an electrical system represents the maximum temperature at which the entire system is designed to operate continuously and safely. This rating is not simply an average of the component ratings, rather, it's determined by the lowest rated component within the system. This means that even if most components can withstand higher temperatures, the weakest link dictates the overall system's temperature limit. For instance, if you have breakers and panels rated for 75 degrees Celsius but a transformer rated for 90 degrees Celsius, you might be tempted to assume the entire system can handle 90 degrees Celsius. However, this is a dangerous misconception. The breakers and panels, being the lowest rated components, limit the system's safe operating temperature to 75 degrees Celsius. Therefore, it is crucial not to exceed this temperature to prevent damage or failure. Always consider the lowest rated component. In practice, this means carefully reviewing the nameplate data and technical specifications for each component in the electrical system. The nameplate typically provides critical information, including the temperature rating. You need to be aware of this rating to ensure compliance and safety. In scenarios where the transformer has a high temperature rating, such as 90 degrees Celsius, while the breakers and panels are rated lower, like 75 degrees Celsius, it's important to select conductors with an ampacity suitable for the lower temperature rating. This ensures that the conductors themselves don't become a source of excessive heat, potentially compromising the integrity of the entire system. The National Electrical Code, known as NEC, provides guidance on conductor ampacity based on temperature ratings. Specifically, NEC Table 310.15b16 lists the allowable ampacities for various conductors based on their insulation type and temperature rating. When choosing conductors, it is necessary to refer to this table and select a conductor size that is appropriate for the 75 degrees Celsius temperature rating, even if other components have higher ratings. This might mean using a larger conductor size than initially anticipated, but is a necessary precaution to maintain safety and reliability. Furthermore, it is important to consider the ambient temperature in the environment where the electrical system is installed. High ambient temperatures can exacerbate the heat generated by electrical components and conductors. NEC Section 310.15 addresses ambient temperature correction factors, which must be applied to the conductor ampacity ratings to account for elevated ambient temperatures. These correction factors reduce the allowable ampacity of conductors, and it is necessary to apply them diligently to ensure that conductors are not overloaded in hot environments. In addition to temperature ratings and ampacity, it's essential to ensure proper ventilation around electrical components. Adequate ventilation helps dissipate heat and prevent components from overheating. Restricted airflow can lead to localized hot spots and premature failure of equipment. Therefore, it is important to follow manufacturers' recommendations for clearance and ventilation around breakers, panels, transformers, and other heat-generating components. Regular maintenance and inspection of electrical systems are also crucial for identifying and addressing potential overheating issues. During inspections, look for signs of discoloration, deformation, or other damage to conductors, insulation, or components. These signs may indicate excessive heat or overloading. Infrared thermography can be used to identify hot spots that are not readily visible. This technology allows technicians to scan electrical equipment and detect areas of elevated temperature. Any detected hot spots should be investigated and addressed promptly to prevent further damage or failure. In summary, understanding and adhering to temperature ratings for breakers, panels, transformers, and conductors is of utmost importance for ensuring the safety, reliability, and longevity of electrical systems. Always consider the lowest rated component in the system, select conductors with appropriate ampacity, account for ambient temperature, ensure proper ventilation, and conduct regular maintenance and inspections. By following these practices, you can minimize the risk of overheating and maintain a safe and efficient electrical system. Let's delve into some additional details related to these concepts. Firstly, regarding breaker and panel temperature ratings, it's important to note that the specific temperature rating can usually be found in the equipment's nameplate. This nameplate provides critical information about the device, including its voltage rating, current rating, and temperature rating. The temperature rating is often expressed in degrees Celsius, and it indicates the maximum ambient temperature at which the breaker or panel is designed to operate safely at its full rated current. Exceeding this temperature can lead to nuisance tripping of the breaker or damage to the panel components. Secondly, when it comes to transformers, the 90 degrees Celsius temperature rise rating is a common standard, but it is not universal. Some transformers may have different temperature rise ratings, so it's always essential to consult the nameplate data and manufacturer's specifications to determine the correct rating for a particular transformer. The temperature rise rating refers to the increase in temperature of the transformer's windings above the ambient temperature. This temperature rise is caused by the losses within the transformer, such as core losses and copper losses. These losses generate heat, which raises the temperature of the windings. The 90 degrees Celsius temperature rise rating indicates that the transformer is designed to dissipate this heat effectively without exceeding its insulation's temperature limits. Thirdly, when considering the overall system rating, it's important to think about all the components in the circuit, not just the breakers, panels, and transformers. Other components, such as conductors, connectors, and devices, can also have temperature ratings that affect the overall system performance. For example, if you have a long run of conductor that passes through a hot environment, the conductor's temperature rating may become the limiting factor for the entire circuit. In such cases, it may be necessary to increase the conductor size to compensate for the increased temperature and ensure that the conductor does not overheat. Fourthly, the National Electrical Code, or NEC, provides detailed guidance on how to select conductors and other electrical components based on their temperature ratings and application. NEC Table 310.15b16 lists the allowable ampacities for various types of conductors based on their insulation temperature rating. This table also includes correction factors for ambient temperature and the number of current carrying conductors in a raceway or cable. These correction factors are applied to the conductor ampacity to account for the effects of heat and mutual heating. It's important to consult the NEC and follow its guidelines when designing and installing electrical systems. Fifthly, proper ventilation is critical for preventing overheating of electrical components. Enclosed panels and equipment rooms should be adequately ventilated to allow heat to escape. Ventilation can be achieved through natural convection or forced air cooling. Natural convection relies on the natural movement of air due to temperature differences. Hot air rises, creating a flow of air that carries heat away from the equipment. Forced air cooling uses fans to circulate air and provide more effective cooling. The choice between natural convection and forced air cooling depends on the size of the enclosure, the amount of heat generated by the equipment, and the ambient temperature. Sixthly, regular maintenance and inspection of electrical systems are essential for detecting and preventing overheating problems. During inspections, look for signs of discoloration, melting, or other damage to components. Check for loose connections, which can cause arcing and overheating. Use an infrared thermometer to measure the temperature of components and identify hotspots. If you find any problems, take corrective action immediately to prevent further damage or failure. Seventhly, in addition to the temperature ratings of individual components, it is also important to consider the temperature class of the overall electrical system. The temperature class refers to the maximum surface temperature that the equipment is allowed to reach under normal operating conditions. This is particularly important in hazardous locations where the presence of flammable gases or dust can create an explosion hazard. Electrical equipment used in hazardous locations must be designed and certified to meet specific temperature class requirements. The temperature class is typically indicated by a T-code, such as T3, T4, or T5. Each T-code corresponds to a maximum surface temperature. It is important to select equipment with a temperature class that is appropriate for the specific hazardous location. Eighthly, when selecting conductors for electrical systems, it is important to consider not only the ampacity of the conductor but also its insulation type. Different insulation types have different temperature ratings. Some common insulation types include THHN, THWN, THW, and XHHW. THHN and THWN are both thermoplastic insulations with a maximum temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THW is a thermoplastic insulation with a maximum temperature rating of 75 degrees Celsius in both dry and wet locations. XHHW is a cross-linked polyethylene insulation with a maximum temperature rating of 90 degrees Celsius in both dry and wet locations. The choice of insulation type depends on the application and the environmental conditions. Ninthly, when installing conductors, it is important to follow proper wiring practices to avoid overheating. Avoid bundling conductors tightly together, as this can trap heat and reduce their ampacity. Use cable ties or straps to secure conductors neatly, but avoid over-tightening them. Ensure that conductors are properly terminated at breakers, panels, and other equipment. Loose connections can cause arcing and overheating. Tenthly, it is important to remember that the temperature ratings of electrical components are based on specific test conditions. These test conditions may not always reflect the actual operating conditions in the field. Factors such as altitude, humidity, and vibration can affect the temperature of electrical equipment. Therefore, it is important to use good engineering judgment and consider all relevant factors when designing and installing electrical systems. Always consult with a qualified electrical engineer or electrician if you have any questions or concerns. Electrical systems can be dangerous if not properly designed and installed. Taking the time to understand and follow the temperature ratings of electrical components can help to ensure the safety and reliability of electrical systems. Therefore, a solid comprehension of the standards and recommended practices is necessary. The information provided serves as a guide. Always check with a qualified electrician for detailed advice. The concepts outlined are intended as guidelines to increase the knowledge about electrical systems and components. It is not intended to be a replacement of official guidelines or recommendations from experts in the trade.